Wait a minute. Let me discuss the. Ifra, did you submit the assignment?
Yes, sir. I have submitted the latest assignment. I have submitted at 8 o'clock today only, but rest I have submitted.
Okay, 8 o'clock. Saifullah, what about you? Did you submit the assignment, the latest one?
So check and see.
Krishna, what about you?
Yes, I have submitted, sir. I have two questions doubts, sir, in that assignment.
Okay, let me see the. Is it uploaded or not? It's not uploaded yet. Okay. Arslan, did you submit the assignment, the latest one? Okay. Now we'll discuss when it will be uploaded, most probably in the next class. Okay, will that be okay?
Okay, sir, no problem.
Okay. So everyone is here except for us. We had a relation between Kp and Kc. That is basically Kp is equal to Kc RT raised to the power delta Ng, right? So I'm going to make 3 cases of this. Okay, we're going for case 1. Just take it. Case 1, a reaction is given in which N2 in gaseous state, N2 in gaseous state plus 3H2 in gaseous state will give 2NH3 in gaseous state. Can anyone tell me the value of delta Ng? Anyone?
-2, sir.
Yes,
Negative
sir.
2. That is -2. Very good. Very good. Now, as we know that there is a relation that is Kp is equal to Kc RT raised to the power delta Ng. So if we are going for we have a relation Kp is equal to Kc RT raised to the power delta Ng. Kp equals to Kc, and here it is RT raised to the power -2. And we can also write Kp is equal to Kc upon RT raised to the power 2. So can anyone tell me which one will be greater, Kp or Kc? Anyone?
So Kc is greater than Kp.
What about you, Ifra, Fawaz, Arsalan, Saif? If I'm giving you this relation, Kp is equal to Kc upon RT raised to the power 2. That means basically Kp is equal to, when we divide Kc by RT raised to the power 2, that means Kc is greater than Kp. Everyone okay with this?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, thank you. So you can easily say that Kp is equal to Kc raised to the power Kc upon RT raised to the power 2. That means we got Kp by dividing Kc by RT raised to the power 2. So whenever delta Ng less than 0, that means negative delta Ng in negative, Kp will be Kc will be greater than Kp. Kc will be, or you can say Kp is less than Kc or Kc greater than Kp. These are same things. Everyone got it?
Yes, sir.
Yes, sir.
Fawaz, Arsalan.
Yes, sir.
Yes, sir.
Just write it. This is the case 1 in which delta Ng basically less than 0. Just write it and let me know if you are done with this.
Done, sir.
Fawaz, are you done?
1 minute, sir.
Wait a minute, I just scrolled it off. Very good, Ifra. Saif,
Yes, sir, done, sir.
Fawaz.
Done, sir.
Okay. Going for case 2. And in case 2, I'm going to take a reaction like H2 in gaseous state. Now, I will ask from a particular student. Don't answer me until you listen your name. 2HI in gaseous state. Now, Fawaz, what is the value of delta Ng for this reaction? Fawaz, what is the value of delta Ng for this reaction?
Sir, 2 होगा.
Very good. Saif, Saif, I'm asking from you, what is the value of delta Ng for this reaction?
I use 0.
0. Very good. Fawaz, delta Ng equals to what? Number of moles of gaseous product minus number of moles of gaseous reactant. So what is the number of gaseous number of moles of gaseous product? That is 2. And what is the number of moles of gaseous reactant? Here 1 reactant and here 1 mole of reactant and 1 mole of reactant. That will be total 2 mole of reactant will be equals to 0. Now we already know that Kp is equal to Kc RT raised to the power delta Ng. Now going to put the value of delta Ng RT raised to the power 0. So anything has a power 0 will be equal to 1. So Kp is equal to Kc. So whenever delta Ng equals to 0, that means Kp is equal to Kc. Everyone got it?
Yes,
Yes,
sir.
sir.
Very good. Just right.
Done, sir.
Done, everyone. Fawaz, Saif.
Yes, sir.
Very good. Fawaz, are you done with this? Arsalan? Fawaz, I'm asking from
Yes,
you.
done, sir.
Okay, thank you. Moving to the case 3. Fawaz, you tell me PCl5
Yes,
in
sir.
gaseous state. I'm going to give PCl3 in gaseous state. And Fawaz, what is the value of delta Ng here? Value of delta Ng.
Sir, 1 होगा.
1. because number of moles of gaseous product, that will be equal to 2, right? And
Yes,
number
sir.
of moles of
Exactly.
gaseous reactant will be 1. 2 minus 1 will be 1. And we already know that Kp is equal to Kc, RT raised to the power delta Ng. So if you are going to put the value 1, then you can see we are getting Kp when we multiply something in Kc, that is RT. So from this equation, you got it, Kp greater than Kc, right? Ifra,
Yes.
Mohammed,
Yes, sir.
Saif. Okay,
Yes,
just
sir.
write it. Thank you. Let me know whenever you are done with this. Very good.
Done, sir.
Done, sir.
Done, everyone? Saif?
1 minute, sir.
Okay, take your time.
Done, sir.
Very good. Now a new topic. Right, a new topic. Lechatliers principle. Lechatliers principle. First, I'm going to write what does this principle say, and then I will explain. So, according to this principle, a change or a change in any of the factors, a change in any of the factors that determine conditions of system, conditions of system will cause the system to change in in such a manner. Wait a minute. Wait a minute. I just determine the equilibrium condition. The equilibrium conditions of a system will cause the system to change in such a manner, or such a manner so as to reduce or to counteract, write with me, the effect of change, the effect of the change. And another which is very important point, then I will explain it. This is applicable to all physical and chemical equilibria. Equilibria is the plural form of equilibrium. This is very important point. Just write it and let me know if you are done with this. Then I will explain it. What exactly Lechatliers principle says. According to this principle, a change in any of the factor that determines the equilibrium conditions of a system will cause the system to change in such a manner so as to reduce or to counteract the effect of the change.
Done, sir.
Done,
Done, sir.
everyone. Saif,
1 minute, sir.
okay. Arsalan, Ifra,
Yes, sir. Done.
okay. Now see, Ifra, are you done with this?
Yes, sir.
Okay. So what I want to say, or what does this principle say? Whenever a system is in equilibrium, whether it is physical equilibrium or whether it is in chemical equilibrium, if the system is in equilibrium and from any external effect, if any external effect or external agent applied to the system that affect the equilibrium, that change the equilibrium, then what happens? System adjusts itself in such a way that equilibrium is not disturbed, or in such a way, in such a manner, the system adjusts itself in such a manner that it reduces the effect or counteract the effect of change. Like, what I want to say is that if a reaction is like, just see here, A is converting into B and it is in equilibrium. Let's just say it is in equilibrium. It is in equilibrium. And what you do after it maintains at equilibrium, and you just increases the, you just take some moles of some concentration of A and just put it on reactant side. That means you just increases the concentration of A, increases the concentration of A. Then system will what will system do? Here you can see the concentration of A increases. That means system will shift to the right side so that equilibrium should not be affected, or system will shift to the right side, equilibrium will shift to the right side to counteract the effect of change. Are you getting my point? If you are increasing the concentration of A, the equilibrium will shift to the right hand side. If you will increase the concentration of B, then system will shift to the left hand side. And I am just taking one example as a concentration for external agent. Either it will be concentration, pressure, temperature, or any other things like if you are adding some inert gases, what will affect it? You just increase the volume of container by dilution, or you just decreases the concentration. It's all basically external agent. External agent means all of it. Okay, so what does this principle say? Whenever you try to change the equilibrium, or you just add some external effort, you just add some external agent, the system will try to nullify the change. Are you getting my point?
Yes,
Krishna,
sir.
Yes, sir. Yes, sir.
Saif, Saif,
So can you explain the
Hmm.
uh, example again?
What you just said?
Can you explain the example? again?
Okay, I will explain it again. Fawaz,
Yes, sir. Yes,
Arslan,
yes.
Fawaz, did you get it?
Sir, little bit, sir. Can you explain again?
Okay, I will explain it. Basically, what I said is just let me know if you got the Lechatliers principle. Lechatliers principle says that if a system is in equilibrium and by some means it is disturbed, like if you are going to increase the concentration of A. Okay, just let me take another example from our day-to-day life. Saif, am I audible to you?
Yes, sir.
Okay, just see. Here is tank one, or you can say container one. It is full of water. It is full of water. And here is a container for this time. At this time, it is empty. Now, what you do is you just take a pipe and hole in the first container and connect it to the another container. Okay, Saif?
Yes, sir.
Now, what happens, you know that after some times, this will be like it maintains its, just suppose it will level up to one another. This much water will be moved to the second container and it will be like in equilibrium. Got it, Saif?
Yes, sir.
Now, if you are going to just suppose this is the equilibrium scenario. This is the equilibrium scenario. And now if you are going to, this is A and this is B. Now, if you go and put some more volume or water in this container, what will happen? It will move to the right direction.
Yes, sir.
Yes, sir.
Saif, very good. It will move to the right direction. That means it won't. They don't want to disturb its equilibrium. And if you want, if you will put some water in this, what will happen? It will go to the left direction. Right, Saif?
Yes, sir.
So in the same way, equilibrium do not want to disturb itself. So if you are going to add some external agent, like if you are going to add concentration of A in the reaction or in the container, what will it do to minimize or nullify its effect, the external effect? It will move to the right hand side. And if you will add the concentration of B, it will move to the left hand side, so that equilibrium should be maintained. Is that clear, Saif? Fawaz?
Yes, sir.
Yes, sir.
This and I just took the example of concentration. I told you I just took the example of concentration. There will be like temperature increment, then equilibrium will be disturbed. Then what will basically anything that disturbs equilibrium shift itself to the direction where the effect, external effect, is nullify or counteract the effect of external agent. Am I clear? Krishna,
Yes,
Ifra, Saif,
Yes, sir.
Yes, sir.
Yes, sir.
Fawaz, and Arslan. Okay. So are you done with this, everyone?
Yes, sir.
yes, sir.
Okay, thank you. Now, I'm going to take examples like effect due to concentration, effect due to temperature, effect due to pressure, effect due to volume. I'm going to take all the examples. So from case one, I'm going to take effect of concentration, and answer me if you are getting my point. You will be able to answer it. This is a reaction in which a reactant is converting into product. Now, Saf, if I will increase the concentration of reactant, where will be the reaction? Which direction, in which direction the reaction will be proceed? Right hand side or the left hand side?
The product side.
Product side, that means the right hand side. If you will increase the concentration of R reactant, it will move to the right hand side. Okay. For us, if I am going to decrease the concentration Krishna,
Sir, you lag, sir. Can you repeat again, sir?
Fawaz, am I audible?
हेलो
Yes, Fawaz, am I audible?
सर आप हैंग हो गए थे तो
Okay. I'm just repeating myself. Am I audible?
हाँ yes
Yes,
sir
sir.
yes
Okay. Now, Fawaz, this question is from you. If we decrease the concentration of reactant, where will be the equilibrium shift? Left or right?
लेफ्ट
Left.
हाँ yes sir
Krishna?
Yes, sir. Left.
Left.
Sir, we are decreasing reactants, right?
Yes. We are decreasing reactant.
So it will be from product to reactant, right?
Left hand side. Fawaz, what I want to tell you is that wherever the effect will be, there will be that side will shift the equilibrium. Like if we increase the reactant side, then it will move to the right hand side, right? And if we will decrease this side, then it will move to the left hand side. Are you getting my
सर मैंने
point,
तो
Fawaz?
लेफ्ट ही बोला था हाँ yes sir
You just said left.
हाँ yes sir
Okay, then I heard it wrong.
हाँ
Okay, is this clear, everyone?
Yes, sir.
Yes, sir.
Ifra?
Yes, sir. It is.
Okay, very good. Now, the second effect. Come for the second effect. Effect of temperature. Effect of pressure. Just take it. Effect of pressure. Always remember, whenever there will be pressure applied, 3H2 will give 2NH3. Pressure increases, it will move to the number of moles. Whenever pressure is increased, it will move to the direction where number of moles is lesser. Are you getting my point?
Yes, sir.
Pressure effect is like when you increase the pressure, it will move to the side where number of moles are lesser. So if we are giving this, if you have given example this and pressure is increased, then the reaction will move to the forward direction. Everyone done with this? If you have any problem, Saf, let me know.
Sir, can you explain pressure again?
If we increase pressure, okay, then equilibrium will shift to that direction where number of moles are lesser. Now, just read it and I'm going to give you a reaction and let me know. 2SO3 and here it will be SO2 and it will be O2. So in this container, if I am going to increase the pressure, where will be the direction of equilibrium? Where will be the direction of reaction? Just say left or right.
Sir, left towards
Saf?
reactant.
Wait a minute. Saf,
Sir, repeat again.
for this reaction, if we are increasing pressure, where will be the direction, left or right? Am I audible clearly, Seth? Or should I repeat it again?
Where are we increasing the pressure in reactants or solid in product?
It will be like left to right or right to left.
Right.
Right. Okay, let me balance it. It is a wrong equation. Now tell me the answer. Now it is balanced. It wasn't balanced earlier. Seth, again, you answer me. I want to ask you again the question. If you increase the pressure in this container for this process, where will be the equilibrium shift, or what will be the direction? Left to right or right to left? What do you think, Seth?
It's right to left.
Right to left. Why right to left? I just wrote, if we increase pressure P, then equilibrium will shift to that direction where number of moles are lesser. Just see, number of moles on the left hand side is 2, number of moles on the right hand side is 3, and if we are increasing pressure, the equilibrium will shift to the direction where number of moles is lesser. Is that clear, everyone? Fawaz?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, going for the next example. Going for the next example, PCl5 is converting into PCl3 and Cl2. Now, if we are going to increase the pressure for this process, for this reaction, for this process, for this container, where will be the direction? Left to right or right to left? Fawaz, you answer me.
Sir, right to left हो.
Right to left. Very good, Fawaz.
अरे शुक्रिया शुक्रिया.
Saif, what will be the answer?
Left to right.
Left to right. Again, you are saying left to right. Just read it once again. If we increase the pressure, then equilibrium will shift to that direction where number of moles are lesser. You can see number of moles on the left hand side is 1 and number of moles on the right hand side is 2.
Yeah, so I'm saying that.
Right to left now. Fawaz,
Oh, yes. in
Yes,
that.
sir.
are you getting my point? Fawaz,
हाँ yes sir. मैंने left ही कहा था.
you told me that left to right, not only left.
नहीं
Okay.
right to left बोला था सर मैंने. ये कैसे हो रहा?
Is everyone
मैंने
listening?
right to
in?
left ही बोला था.
Krishna, Saif,
बता दो कोई यार.
But sir,
what Fawaz answered me? Left
So
to
he
right
said-
or right to left?
so he said right to left, sir.
Exactly.
Yes, sir.
Fawaz, you are lying.
अरे no sir.
You told me right to left. That's why I told you. Very good. There is
And-
always a hidden thing.
हाँ
there.
तो
Okay. Okay. Ifra?
Yes, sir.
Okay. Now answer me. Who is going to answer me? Krishna. This question is for you. H2 plus I2 will give 2HI. Will give 2HI. Okay. If we will increase the pressure, where will be the direction? Krishna, this answer is from you.
So both sides equal moles are there, right?
Yes, yes. Both sides equal mode. Whenever Saf, whenever pressure, there will be the answer in terms of pressure, you will go for number of moles on the both hand side. Reactant as well as product. Very good, Krishna. So tell me the answer, Krishna. Okay. If you are unable to think anything about this, Ifra, what about you? What will be the answer? Where will be the direction?
Sir, it will not move according.
Very good. Krishna, very good. Delta Ng equals to 0. That means whenever delta Ng equals to 0, or you can say the number of moles of reactant is equal to number of moles of product, there won't be any effect. Does not affect by pressure. Does not affect by pressure change. Saif, are you getting my point?
Yes, sir.
Okay, I'm going to slide it up. Let me know if you are done with this. Okay, just write it. Very easy. You just need to, and it is a very important topic. You just need to tell me the answer in terms of direction. Left, right, right, left, where it will move. Very good, Ifra. So I'm again repeating, whenever there will be equal number of moles on both hand side, like left hand side or right hand side, the pressure change won't affect it. Okay. And remember, whenever we increase pressure, the direction will be that where number of moles are lesser. Okay. Arsalan.
Done, sir.
Fawaz, Krishna.
Yes,
Krishna,
done,
you're done. Saif, Arsalan. Saif, let me know if you're done.
Yes, sir. Sir, in second
Done.
example, PCl5, it is left to right,
Yes.
right?
Not left to right, it is right to left. It will move to that direction where
Okay,
number
okay,
of
yes.
moles are lesser. Okay. So on the left hand side, it is number of moles 1, and on the right hand side, it is number of moles 2. So it will move to the higher number of moles to the lower number of moles.
Yes, sir.
Very good. So just write the remaining and let me know. I'll change the slide and move to the next effect of time. Before that, I'm going to give you a question on top. Let me know if you are done with this.
Done, sir.
Done, sir.
done.
Saf?
Yes, sir. Done.
Okay. So here is my question for Saf. 2NH3 will give N2 plus 3H2. Okay. So if we are going to decrease the number of pressure in this reaction, where will be the direction?
So
Will be
towards
from
product.
Are you safe?
Sorry, sir.
Okay, safe
the same towards product,
towards the
reactor
product.
product.
Whenever there will be confusion, just think about increasing pressure. If we will increase the pressure, it will move. Okay, so you both may be wrong. Okay, let's see. What I taught you is whenever we increase the pressure, it will go to that direction where number of moles are lesser, right, Krishna?
Yes, sir.
Yes, sir.
So according to our concept, it will move to the left hand side, right, everyone?
Yes, sir.
Yes.
Now, if we will decrease the pressure, it will reverse. Reactant to product, it will go or not? Ifra?
Yes, sir. I said towards product.
Okay, very good, very good. Very good. And Saif, you are also very good. You both are correct. Okay, moving to the next effect, which is effect of temperature. Effect of temperature. So whenever we are going to predict the direction with the help of Lechatliers principle, we will have to know the first we will have to know whether it is endothermic and whether it is exothermic. So here it will be, I'm just taking the first as endothermic, and everyone knows that endothermic reaction has delta H equals to positive, right, Krishna, Saif,
Yes.
Fawaz, Ifra? Delta is
Yes,
positive,
sir.
that represents endothermic reaction. And what does endothermic reaction means? Heat is given to the system or to the process or to the reaction. For this reaction, heat is required. So if there is a reactant and you need to add the heat to proceed it forward. Okay, everyone?
Yes, sir.
Okay.
Yes, sir.
Yes,
What
sir.
will be the, listen to me carefully, what will be the favorable condition for this reaction in terms of temperature? If we will increase the temperature, it will be favorable condition for this reaction. It will move to the right hand direction to the product side easily.
Yes, sir.
Yes, sir.
Safe.
Yes, sir.
Fawaz, as we know that in endothermic reaction, we require or we need heat. And for that heat required, if we increase the temperature is related to heat. If we increase the temperature, heating effect will start, it will heat it. Okay, so if we increase temperature, reaction will go to the forward direction, right? The direction will be forward. That means reactant to product side. Everyone okay with this?
Yes, sir.
Yes, sir.
Yes, sir.
And if we will decrease the temperature, it will be backward, left, right to left. Forward. Saif,
Yes, sir.
Yes,
Saif, are you clear with this,
yes, yes.
for this? Okay. Okay, thank you. Okay. Come for the second case, which is exothermic process, which is exothermic reaction. And in exothermic reaction, delta H equals to negative, that represents it is exothermic reaction. And you know that heat is given out. Heat is given out from the system or from the process. From the system, you can see. You know that reactant already have a lots of energy in terms of heat. Okay, and it is converting into product and it is releasing heat from itself to stabilize itself, to stabilize. Is that clear, everyone? Krishna, Fawaz?
Yes.
So in terms
Yes,
of
sir.
heat, just remember one thing: stability is inversely proportional to heat energy. Whenever a molecule has higher energy or more energy, it will be less stable, and a molecule which has lower energy, it will be it will be it will be more stable. If a molecule will have lower energy, stability will be greater, and if a molecule will have higher energy, stability will be lower. Is that clear, everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, now see, for this reaction, I am writing delta H is equal to negative, that represents exothermic reaction. And in this reactant has already too much heat. That's why it is releasing heat from itself. And at this time, if you are going to increase the temperature, that means you are giving it heat energy. You are giving it heat energy. That heat energy is not required for this reactant because it already has a lot of heat to release. So this, if you are going to increase the temperature, this will be unfavorable condition for this reaction, so it will be backward. Saf, reactant has already a lot of heats, a lot of heat energy. Has already a lot of heat energy. That's why it is releasing heat from itself. And at that time, you are going to increase the temperature. That means you are going to give some more heat to the reaction that is not favorable for that reaction. That's why it is moving to the product, moving from the product side to the reactant side. Is that clear, Saf?
Yes, sir.
Fawaz, Krishna?
Yes,
Yes,
sir.
sir.
So always just try to understand it. In endothermic reaction, if you increase temperature, that is in endothermic reaction, it requires heat. That's why it is favorable. So it will move from reactant to product side. And in exothermic process, it doesn't require any heat, and you are going to increase the temperature. That means it will bounce back. That means product to reactant. And if you will decrease the temperature, that means it will move to the forward direction. Is this clear, everyone? Just write it and
Yes,
let me
sir.
know if you have any doubt regarding this. Very good, Arslan.
And done.
Done, sir.
Very good. Waiting for you, sir. Saif, are you done?
No, 1 minute, sir.
Okay.
Sir, will it be given that this process endothermic or exothermic, or we should know
Yes,
it?
it will be given, or you have to, you will know about it. Maybe it is given that delta H is positive or delta H is negative, or always remember, whenever there will be bond formation, whenever there will be bond formation, that is exothermic reaction. Or there will be some hints like a reactant plus some heat energy is given. That means this is endothermic, and reactant product plus some heat is given. That means exothermic. Okay, everyone.
Yes,
Okay,
sir.
sir.
Are you
Yes,
done with
sir.
this, Seth?
Yes.
Okay. Okay, let me know. I just told you that stability is inversely proportional to energy. So I am taking a reactant is converting into product. This is basically delta H here is given, as I am giving you delta H is positive. And in this case, reactant is converting into product. And for this reaction, I'm giving you delta H negative. So with this reference, can you tell me in the first process, which is more stable, the reactant one or the product one? Which is more stable?
So product.
In the first case, product is more stable, right?
Yes, sir.
Okay. And in the second case, which one is more stable? Krishna,
react-
which one will be the more stable? Try to answer me the first and then second. Krishna, I got an answer from Ifra. Seth, according to you, which one will be more stable?
Sir, I think it's reactant, sir.
A reactant is more stable in the first.
Yes, sir.
And Ifra, your answer is also the same? Ifra?
No, sir, I said product is more stable.
Product
Sir, I
is
said product is more stable.
okay. Let me tell you that reactant first, just suppose a reactant has initially energy 10 joule, and in endothermic process we give some temperature, we increase some temperature, or we give some heat to this reactant to convert into product, right? Right, Ifra?
Yes, sir.
Now what we do is to give this reactant some energy to convert into product, and energy can neither be created nor be destroyed. Just suppose we give 10 joule of heat, so reactant has 10 joule energy, and for converting it into product, this product has 20 joule energy, right?
Yes, sir. Now I got
Which one
it.
is
I
more
thought,
stable?
sir, reactant is more stable. I
Reactant is
thought that
more
we are
stable.
giving more, we are giving heat to reactant, so it will have more energy.
So when we give heat to
Yes.
the reactant, it is changed
Yes,
into product.
yes. Yes,
Very
sir.
good.
Got it. Yes.
Saf, are you getting it?
Yes, sir.
Now, in terms of this, just see, initially a reactant has 100 joule, and in exothermic process, it is converting into product. So with some heat, that means it released some heat, product had 50 joule, just let's say it will have lesser energy than reactant because it releases some heats. That's why in exothermic process, product is more stable than reactant, and in endothermic reaction, reactant is more stable than product. Fawaz, is that clear?
Yes, sir.
Krishna, Arsalan?
Yes, sir. Clear.
Okay, just write it in your own language. And let me know if you're done with this.
Done, sir.
Done, sir.
Done, sir.
Seth, Fawaz, Seth, are you done with this?
Yes, sir.
Okay. The next effect of catalyst. Effect of catalyst. So remember one thing, does not affect, catalyst does not affect the equilibrium. Catalyst does not affect the equilibrium. Next, this was the fourth effect. Fifth effect of addition of inert gas. So it will have two conditions. Either it is on constant volume or either it is on constant pressure. Okay. So case one, I am going to take a case one. And what does case one says? At constant volume, at constant volume. At constant volume, if you add some inert gases at constant volume, if you add some inert gases into the process or into the reaction or into the container, it won't affect its equilibrium. So I'm going to write it here. Does not affect equilibrium, does not affect the equilibrium. Okay. And case two, at constant pressure, at constant pressure. So at constant pressure, reaction will shift in that direction. Reaction will shift in that direction where number of moles increases. Number of moles increases. So if I'm going to take an example, like if we are going to take an example, N2 plus 3H2 will give 2NH3. And if you in a question, it is given that helium is added in this container, helium is added, then where will be the where will be the direction of the reaction? So the direction will be there where number of moles increases. That means here 2 number of moles and here 4 number of moles. So the direction will be from left to, sorry, from right to left or from product to reactant. Is that clear?
Yes, sir.
Yes. The reaction will proceed in that direction where number of moles increases. Simple. If you are done with this, let me know. Very good, Ifra.
Sir.
Very good, Fawaz, Krishna, Saif, and Fawaz. Sorry, Arsalan.
So can you explain the example again?
Okay. Just see. Is there any doubt in this? This? Is there any doubt in case one,
No,
fifth,
sir.
or fourth? So for second, whenever inert gases are added at constant pressure, so the reaction will shift in that direction where number of moles are greater. So you will see product side has 2 number of moles and reactant side has 4 number of moles. And if you add in this container, this is the container in which the reaction is going on. And if you are going to add helium, argon, or the noble gas, inert gas, that means helium, neon, argon, krypton, xenon, radon. From this, from this list, we are going to add any one of them. Then the reaction will move to that direction where the moles are greater. So it will move to right to left. Simple. Is that clear,
Yes, sir.
Saif? Can I change the slide?
No, wait a minute, sir.
Okay.
Done, sir.
Wait a minute. Please wait a minute. Okay, so I'm going to give you a question. Predict the direction of equilibrium or direction of friction. Predict the direction of equilibrium. In which N2 in gaseous state plus 3H2 in gaseous state will give 2NH3 in gaseous state. So the question is that if we are going to increase the concentration of nitrogen, where will be the direction? If we are going to increase the concentration of NH3, where will be the direction? Third question is, if we are going to increase the pressure, where will be the direction? Fourth is, if we are going to increase the temperature, where will be the direction? Fourth. Fifth is, by adding catalyst. If we are going to add catalyst in this process, then where will be the direction? Sixth is, if we are going to add inert gases at constant volume, where will be the direction? And seventh is, at constant pressure. Can you solve it?
Yes, sir. So it is an exothermic reaction.
Yeah, it is an, yes, it is.
Exotherm.
It is an exothermic reaction. Delta is negative. So if you are done, Ifra, let me know
Yes.
the direction in the chat box. Like one, directly you will write if you are going for one, right?
Okay, sir.
And two, it is left or right, whatever. Third, left or right. What is the whatever is the answer to the direction? Okay. And if you want to write all in all format, you can. Krishna,
Yes, sir.
how many questions you are solved till?
Sir, I'm solving, sir. I think I'm in question number 6, sir.
Oh, very good. Very good, Ifra. Very good. Very good. Very good. Saf, on which number of question you are?
Fourth one, sir.
Fourth one. Very good. Very good, Ifra. You are done with 7th question. What about you, Fawaz? Oh, very good, Fawaz. I didn't expect that this much accuracy in your answer. Very
Thank you,
good.
sir.
Okay, waiting for the answer of Krishna, Saf, and the never spoken man, Arsalan. Should I write the answer? Okay, I'm going to write the answer. Saf, are you done with this?
Yes, sir.
Okay. Fawaz, you are done, already done. Okay. Arsalan, Krishna, are you done with the all question?
Yes, I'm just sending, sir.
Okay. Okay. This is, in this case, left to right towards product, and in this case, towards reactant. In this case, towards right, and in this case, towards left. No effect because on addition of catalyst, no effect. Okay. And then no effect at constant volume, and in this case left, towards left. Very good. No change. Very good, everyone. Saif, are you all your answer is all right, or is there any mistakes?
No, sir. Everything is right.
Very good. So can I change the slide? Can I change the slide?
सर लास्ट वाले का क्या है?
It is from right to left. Whenever we add inert gases at constant pressure, it will move to the direction where number of moles are greater. So here is 2 number of moles and here is 4 number of moles. So it will move like this. Okay.
ओके सर.
Okay. Moving to the next topic, which is application of equilibrium constants. Application of equilibrium constant. So here is the application. Basically, we can predicting the extent of reaction. If we know the value of equilibrium constant, we can predict the extent of reaction, how much it will go to the forward. That means how much approximately how much product will form, how much reactant will form, and like this. So how we predict is it depends upon the value of equilibrium. So if Kc is greater than 10 raised to the power 3, that means it will move to the right hand side, or it product will form, or products predominantly products predominate over reactants. Right with me? That is, Kc is very large. Kc is very large. The reaction will the reaction proceeds nearly to completion. The reaction proceeds nearly to completion. That means very less amount of reactant will left remain in the equation. The reaction basically is completed by converting reactant into product. All the we can say approximately all the reactant converted into product if Kc is greater than 10 raised to the power 3. If you are done with this, let me know.
Done, sir.
Done, everyone? Saif, Fawaz, Arsalan, Ifra.
Wait, sir.
Yes, sir. Done.
Okay.
So what does it mean that
Done, everyone?
reaction proceed nearly to completion?
That means almost all the reactants are converted into product. Very less, very, if you have 100 molarity of reactant, that means 99.9, or you can say 99.5 or 99 plus is converted into product. Is that clear?
What
Sir?
happens to the remaining ones?
Remaining ones will be maintain equilibrium. It is not necessary to have the same concentration of reactant and product to maintain equilibrium. The rate of reactant, the rate of forward and rate of backward reaction should be equal, must be equal. Okay. The third graph that I plotted in concentration versus time is like this. In third or second graph, it was like this, and it was like this. This represents basically this situation, because initially it was just suppose 100 molarity, it was 0, and after that time it is the product is basically 100 molarity, or it is very less, but it maintains equilibrium. Is that clear, sir? Since we are studying a chemical equilibrium, it is in equilibrium. Okay, Saif?
Yes, sir.
Okay. Moving to the case second, if Kc is less than 10 raised to the power minus 3, very less, reactants predominate. Reactants predominate over products. That is, if Kc is very small, which is here it is, if Kc is very small, the reaction proceeds rarely. The reaction proceeds rarely. Okay. This was the situation in which we can say like this: concentration versus time. The reactant is like this and it is like this. Product is like this. Product is very less. Reactant has more quantity. That means it is rarely going to a product side. And if Kc is in between these two, if Kc is in the range of 10 raised to the power minus 3 to 10 raised to the power 3, that means appreciable concentrations of both. Appreciable concentration of both reactants and products. Reactants and products. You can say almost equal. Appreciable reactants and products are present. This is the third case. Okay. Is this clear, everyone?
Yes, sir.
Yes, sir.
Done, sir.
Saif, Krishna, Fawaz.
Done, sir.
Okay.
1 minute, sir.
Okay, take your time. You are done with the above one, the second B part. Okay. So in NCERT 2, it is given like this. This represents, basically this arrow represents the value of Kc. The value of Kc. So I can write this extremely large. Everyone can see the screen.
Yes,
Yes,
sir.
sir.
This is Kc, and here it is 10 raised to the power minus 3. Here it is 10 raised to the power 3. From this to this, basically, both the reactants and products are present at equilibrium. At this point, a reaction hardly proceeds. And at this point, a reaction proceeds almost to completion. Reaction proceeds almost to completion. Done, everyone?
Yes, sir. Done.
Krishna?
Just a minute, sir.
sir.
Done, everyone? Fawaz, Saif?
Wait, sir.
Okay, okay. Take your time.
Yes, sir. Finished.
Very good. Thank you. So moving to the next application, which predicts basically direction. This value depends. The value of Kc says that, like, if Kc greater than 3, products predominates. That means the reaction will proceed to completion. And if the value of Kc is lesser than 10 raised to the power minus 3, that is reactant predominate. That means the reaction is hardly or rarely proceed to the right hand side. And if the value of Kc is in range like 10 raised to the power minus 3 to 10 raised to the power 3, the reactant and products concentration both are appreciable. That means comparable, you can say. Okay. So the second application is predicting the direction of, am I visible?
Yes, sir.
Yes, sir.
Okay. Predicting the direction of reaction. Now we will have a new term which is known as reaction quotient. Reaction quotient, and it is denoted by QC. It is denoted by QC. It is calculated in the same way as we calculated equilibrium constant. Do you know what is equilibrium constant? Ifra? Saif?
So K.
K or Kc, you can see. Kc is
Yes.
equilibrium constant, and this represents basically only the equilibrium constant, only the equilibrium situation. Saif, am I audible to you?
Yes, sir.
So Kc represents only the equilibrium situation. Okay, and this Qc is for all the time during the reaction. Like if we are writing AA plus BB will give CC plus DD. And if there is written that Kc is equal to C raised to the power C, D raised to the power D upon A raised to the power A and B raised to the power B, that means this situation is at equilibrium. This situation is at equilibrium. But if this, if QC is written, QC is calculated in the same way that we calculated Kc, that we calculate the value of Kc. So it will be like C raised to the power C, D raised to the power D upon A raised to the power A and B raised to the power B. And this QC is at any situation or any concentration, at any concentration. That means QC is for all the time in the process, and Kc represents only at equilibrium. Whenever we use Kc, that means the situation is at equilibrium, and QC is for including equilibrium from t equals to 0 to t equals to equilibrium. Is that clear, everyone?
Yes, sir.
Yes,
Krishna?
sir.
Saif? Saif?
Yes, sir.
Fawaz?
सर आप फिर से एक्सप्लेन कर सकते हैं?
Yes, why not? Why I am here, Fawaz? Why I am
हाँ
here? To explain
yes,
again
sir.
and again. Okay. So what I want to say is that Kc only represents the situation at equilibrium. Okay. And whereas QC represents the situation from t equals to 0. That means when the reaction is about to start, and t equals to equilibrium. That means till equilibrium. QC is represented by t equals to 0 to t equals to equilibrium. In this duration of time, it is represented by QC. Okay. And Kc, whenever there is Kc written, that means the situation is at equilibrium. Is that correct? Or was
Yes, sir.
okay? Just write it and let me know if you're done with this.
So can you scroll a bit down?
Yes, why not? Are you done? Ifra, Fawaz, Arslan.
Yes, sir. Done.
Okay.
Done, sir.
Okay, sir. If you are done, let me know. Arslan. Arslan.
Sir, can you once define a reaction question again?
Reaction quotient is basically it is calculated with the method that we calculated Kc, but this QC is at any time t between the time duration t equals to 0 to t equals to equilibrium, and this Kc is only for the equilibrium situation. Saif, Saif,
Yes, sir.
just take an example of tank that we had took it earlier, right? There is two tank. You can see this is full of water, and you just connected a pipe between them and just hold it. Okay, so you can yeah, what will happen? The water will flow from here to here, this tank, from tank 1 to from tank to the tank 2, and you can calculate QC at any time starting from this tank to this tank. Okay. After some time, this two tank will achieve equilibrium. This two tank will achieve equilibrium, and after achieving equilibrium, we only calculate Kc. But QC is for t equals to 0 to t equals to equilibrium. We can calculate QC at any time. Is that clear?
Yes, sir.
So this is the only example. I'm going to establish a relation between QC and KC. Just remember, if K is if Okay, let's start. Hello, am I audible, Fawaz?
Yes.
Yes, sir.
Okay, if QC is less than KC, I will give you an example. It will be very easy. If QC is less than KC, then net reaction goes from left to right, left to right. Okay, if QC greater than KC, then net reaction goes from right to left. And if QC is equal to KC, no net reaction occurs. No net reaction no net reaction occurs. That means it is in equilibrium. It is in equilibrium. So it's so easy. Whenever there will be the value of KC, and you will have to calculate QC in the same way that we calculated the value of KC. Sorry. So we will compare the value QC and KC, and if QC is less than KC, that means left to right. That means reactant to product side. QC greater, that means backward reaction will happen. And if QC is equal to KC, that means it is in equilibrium. Is that correct, Fawaz?
Yes, sir.
Is there any doubt?
No, no, sir.
Saif?
No doubt, sir.
Okay. If you're able to do it, let me know. I will complete it. But it's so easy. Just try to solve it.
So what is the composition of what mixture, sir?
Composition of reaction mixture. Okay.
Okay, sir.
Okay.